Okay, you ready? Yeah? Okay, sweet. This one's going to be, sad day, 10/3.
Yes.
This one's going to be 2/15.
Oh, I know what happened. I did it wrong.
This one's going to be 8/20, which is 2/5. Now, question. How did I do it mental math? I did it a year ago. I don't remember that. Okay, that's true. But I did it mental math. Does anybody have any ideas as to how they think? Because some of you were like, I can do that in my head, at least one of them. Did anybody out here, or do you think you could do any of these mental math?
I can do the first two.
The first two. Nathan, how would you do the first one?
So, do the 2 times 5 is I don't know. Let's see.
You're doing 2 times the 5 and the 3 and then...
Because it works for both 1 and 2.
Okay, hold on. Let's have him try to explain number 2, and I'll have you try to explain number 1. So number 2, Nathan, let me close the door. Okay. How about number 2? No, go ahead. How do you do it? And number 2.
So, because when we actually do it, you have to flip it.
Okay, you have to flip it.
So, you're just going to multiply the denominator of the top one by the numerator of the bottom one. And then like that.
Because he's saying if you multiply by the flip, the reciprocal, this one gets multiplied by the other, and this one gets multiplied by the other. There's actually a trick that elementary kids, depending on where you learn math, sometimes learn. If a fraction's written by this, it's always going to be the top over the bottom, because multiplied by a reciprocal is actually, a valid trick that is used. And so it's 1 times 2 over 3 times 5, 2/15. That's a mental math way of doing it. So then, Emma, how did you think through number 1?
So it's 2/1 divided by 3/5, but you have to use reciprocal so you can multiply. So it'd be 2/1 times 5/3, and then you multiply across.
Which ends up being 2 times 5 over 3 times 1. So actually, this little trick of, it is technically, as Nathan said, it is multiplying by the reciprocal. And Emma said it too, it is multiplying by the reciprocal. But ultimately, if you can think about the top as a fraction and the bottom as a fraction, it will always work. That is very top times very bottom over the middles. So 2 times 5 is 10/3, or 2/15. My other way of doing it is that I multiply top and bottom by whoever's the stuck little guy. So I do 5/5, and that cancels out, or reduces, I should say, and I get 10/3. And then this one I would multiply top and bottom by 6, but this one's actually a little harder to do it this way, because that would be 1 and 2, so 2, and then 1 and 3, 15. To be honest, I did this one this way with a little trick of the outers over the inners. On number 3, though, let's not go with the mental math way of doing it. Let's just do a way of doing it. What's a way of doing number 3? Who got it right? You already answered one. Justin.
You can make 2 be 10/5, and then subtract.
I like that you, in your brain, are like, 2 is 10/5. That's great. But Kobe, did you do a little math to get there?
That's what I mean.
Oh, you just got straight to 10/5? Did anybody do a little math to get there, or did you all just say 10/5? Oh, no one multiplied by 5/5 just to be cool? Okay, well, you guys are geniuses. So, 10/5. 2 can become 10/5. Justin, keep going. Now what?
Then you subtract by 2/5.
Okay, so 10/5 minus 2/5, 8/5. Good. And then what?
Multiply by 1/4.
Multiply by 1/4, because 4 can become 4/1, right? 4/1 multiplying by the reciprocal is 1/4. But couldn't you also do our trick that we just saw? 8/20, right? My way of doing it, which I think might have been faster in this one, is to multiply top and bottom instead of doing the common denominator. A big old 5 on top and a big old 5 on bottom. 20, I got that fast. And then I said 10 minus, and then that reduced to is 8. Either way. Either. My question is, can you simplify complex fractions with numbers? Because we're about to need to do it with trig. Nikki.
For the first two, why can't you just do the reciprocal?
You can. I was just showing mental math. Sometimes it's a little bit faster. If you can get it to that. And then like Nathan was doing the reciprocal, but he was seeing it ultimately, and so I just kind of drew that comparison. But yeah, both Nathan and Emma said like multiply by the reciprocal as to how or why they were doing what they did. So yeah, it's not wrong. It's not wrong. But just a few of you were kind of like, oh, that's a nifty trick. I kind of like that. That's cool too. What did I just say as to why we practice with numbers first? God. Where are we at in our notes right now? Oh, sorry, I don't mean it in like a literal way. I mean it in like a. Where are we at in the midst of chapter 5? What we're covering today so far? Identities. What about identities? We are just looking at them, memorizing them, using them, or verifying them. We're trying to get to the point where we can see something they're telling us is true, and we can show why. And you might be like, well, this is dumb. Well, remember, they're trying to get you to the point where you can now use the skills that you've developed to take a nasty expression and make it simpler for the purpose of being able to actually finish a problem. Does that make sense? Okay, let's get all phones put away. Let's get all brains focused on the task at hand. We're back in section 5.2, trying to do as many sample problems as possible. Why did I have you practice complex fractions? Write down this problem and see where you would start. Maybe you'll know there's none. This does not have a complex fraction. Yet. This does not have a complex fraction. Some of you just wrote it down and you're just kind of waiting. Just kind of chilling. Figuring I'm going to come up and start doing it. But from yesterday, shouldn't you at least, or shouldn't you at least be able to, get the first point of any problem that you're going to need to do? At least do that. Because didn't I say that was worth at least a point? Now, why did I choose that side? More complicated. And maybe if you've at least gone that far, maybe you're like, well, maybe I'll at least try something. Wasn't that step number 5? Always try something. And maybe you're looking at your formulas from the beginning of 5.1 because you remember that I said anytime you have to do problems in homework, on the test review, on the test itself, you get to be looking at formulas. Problems. Nathan, what's up?
Can you use Pythagorean identities even if it's not squared?
No. That's the bummer.
That's what I thought.
But that's a valid question because a lot of people are going to try or want to because doesn't this look an awful lot like Pythagoreans?
Yeah.
But no squaring. So then that begs the question, well, why can't we just square both sides? No, that's not the point. The point isn't to play with both sides and just get rid of stuff. The point is to show how to take the left and be like, in a future problem, I might see when I really would need to get you to that simpler thing to possibly solve. So you're showing that you can get from the more complicated to the simple. Because in the future, you won't have that other expression. You have to find it yourself. I saw other hands all over Justin.
Can't you just substitute one for x squared plus x squared?
But there are no squares. That was Nathan's question. Can we use Pythagoreans if there aren't squares? And we can't put squares on both sides, so that's illegal. And even if we did put squares on both sides, we would have to FOIL and it wouldn't look as nice as we would like. Although you could multiply by a conjugate. Secant theta minus, no, sorry, secant theta plus 1, secant theta plus 1, and you could multiply by a conjugate. It might make it worse than you might like, but a conjugate is legal to get a Pythagorean. Did I misread your question? You asked if you could use one of the Pythagoreans, right?
Yeah, I was saying if you could substitute one.
Oh, I see. I mean, you could technically make the 1 itself sine squared plus cosine squared. I just don't know if you'd want to. I see what you're saying. You could technically. 1 does equal sine squared theta plus cosine squared theta, but I'm not sure you could combine any like terms. You could use sine squared to be 1 minus cosine squared and try to factor a quadratic. Okay.
Take the cosine of theta and switch it for 1 over secant.
Ooh, he's looking at, if you guys are looking at your identities 5.1, he's thinking the reciprocal identity of cosine. Why on earth would Nathan, does anybody agree with him first of all, and you thought of getting rid of cosine? Did anybody think? Sid did, Griffin did, anybody else think of getting rid of cosine? Sweet. Diego? Kayla? Why are so many people aiming for the cosine? Now I know it's not the majority of the class, but I agree with them completely. Why would you get rid of the cosine? Griffin?
I think I got it.
Nice.
Can you change 1 minus cosine to sine?
Oh, sorry. Illegal. Really good idea. Really good idea. And to be honest, Griffin, that's exactly what Nathan was wanting to do. And to some extent, I think, Justin, they were wanting to get the Pythagorean properties in. But pause. Look at those Pythagoreans. I know it's tricky. You're basically killing puppies. All of you, we have to have squares for those to work. Because if I did take that Pythagorean property that multiple ones of you are wanting to use, ready? This we know to be true, right? This is true. Completely, totally. And some of you guys are like, I see the 1 minus cosine. Can't I just erase it and do sine? Okay, now some of you are more mathematical than that. Like, okay, I didn't just erase the squares. Like, I was like, oh, if that's true, then isn't the square root true? This is what you're doing in your head without realizing. Subconsciously illegal math. Subconsciously you're criminals. I could totally go in like deep in the gospel right now. That'd be fun. Just come back. I'm into gravity. But why can't we say 1 minus cosine cosine?
Because it'd be true if it was radical 1 minus cosine.
If it was radical 1 minus radical cosine squared, that would work. But can I distribute a square root of? No. That's killing the company. Does this side equal sine? Yeah. Well, technically absolute value. But yeah. What does this equal? I don't know, because there's no perfect squares. These two are different, they're not the same. I can't square root a non-squared expression. I'm so sorry, it's illegal. So, I like the idea of my ones thinking, because you're going to the properties and saying, oh, this looks good, but it's just not going to work, because it's based on an illegal jump. Can we go back to those of you that were thinking of just getting rid of the cosine? And I think some of you were trying to get rid of this using that. Okay, stop, dead end, come back. It's okay. Dead ends are valid too, or useful too. What's another way of getting rid of the cosine? Pause. Why are we even getting rid of the cosine? Why are people looking here and not looking there? Secant. I just don't want the cosine. Okay, so Nathan, what was your idea as to which?
Switch cosine with 1 over secant.
So once he asked that question first, some of you missed it because you were thinking and pondering, and I loved it, and I still love it. He jumped ahead and said, okay, fine. If I can't do that, what can I do? Well, okay, fine. Cosine of theta is 1 over secant. Okay, cool. At least I still have secants. Why did I have you practice complex fractions? It's a complex fraction. Is it like the first one, the second one, or the third one? Yeah, because it's a fraction within like an expression within a fraction. Kimia.
You subtract, you do the problem on the bottom,
Okay.
and then you flip it and multiply it.
Okay. So if I want to flip and multiply, then I'm just going to keep this top the way it is for right now, right? Doing the problem on the bottom. Now I know some of you were awesome and you were like, hey, this guy is 10/5. And you were right, but I don't know if your brains would go to secant over secant. Maybe it would, maybe it wouldn't. I'm just doing common denominators, right? Now I have a common. Now I have a secant theta minus 1. Ooh, and some of you were like, I like that. Just be careful. If you finish with 1 over secant, that's wrong. If you finish with multiplying by the reciprocal and then reducing, or if you see that this guy could be over 1, can't I say these guys over those guys? Ultimately, these guys reduce. I end up with 1 over 1 over secant, which ends up just being secant alone. And if you used my trick, then you would have come up here. Let's see. To be honest, my trick, I'm in blue now, I think. Yeah, right here. I wouldn't have done that little baby secant over secant in the midst of the denominator. I would have done the secant over secant outside. And I would have distributed in. So secant minus 1, and my secant would have already been in its proper location in the top. So I would have had my secant theta minus 1. My secant theta minus 1 would have reduced, and my secant would have been in his proper location. That's why I like my trick a little bit better, taking that stuck little baby denominator, multiplying top and bottom by. It just makes it more efficient, and you don't have as many places to make mistakes, but all of those methods would work. But I love any of you that thought of somehow getting rid of the cosine. I know there's a little fly and you won't get out. I think the middle schoolers are gone. Let me open the door. He's been in here since like yesterday. It doesn't make sense. I thought they were supposed to die in like 20 minutes. But... Anyone? Want a petition for new door stops? Anyway. Did we prove it? Yes. Is proving just a snazzy way of saying verifying? Sure. So, go play with this one. No, he looks so much worse. No, he doesn't, because he's not going to have a complex fraction. What side are you guys going to use? Go for it. It'll be a party. Everybody else, please start with the left. But remember, if you're bored in class, try to go the other way. Whenever you go from something simpler to something harder, you're going to have to introduce expressions that reduced away. So you're going to have to think like twice as hard. Because you're going to have to think of, okay, wait a minute. What does he have that he doesn't have? What must have canceled out? How can I be creative enough? Okay. I would start with the left. Have you gotten your formatting point? Have you drawn a T and rewritten? Come on, everybody get at least a point. And then if you thought, well, I at least started it, maybe I should try something. Good. Maybe you get another point just by making a legal step, whether or not it's the right legal step. Some of you, it's going to be so easy to give up on these. And that's for those of you that actually try your homework. Some of you give up before you even get to homework. But hold on. Always try something. Can I help just a second? Can I tell you the 2 questions you should ask yourself once you've chosen a side? Should I try to plug in, go look at your formulas, or should I try to do math? Think about some sort of algebraic mathematical step? Is there anything to FOIL?
No.
Anything to factor?
No.
No. Anything to combine? Not yet. Where's my brain going? I'm skipping plugging in completely. I'm going straight to anything to factor, no. Anything to FOIL, no. Anything to combine, not yet. What do I mean? I have two different fractions. I would love to start combining stuff, but I can't even go to adding until I get louder. Common denominators. I'm going to start with math. But remember, this all came from me asking one question. Should I plug in, go straight to identities like the last example, or should I do math? And I'm like, fractions? Let's put them together. See what happens. We've done enough of these. You guys did common denominators in 5.1. Pause, pencils down, turn to people in your group and see if everyone has started the common denominator steps properly. If not, help them get there. And don't go back to your problem until they have. You don't get to stay in these groups much longer. Monday. But you should be comfortable enough to be like, write it down. Wait, I can show you what they've done.
I was kind of lazy to do this, so I just kind of scrolled for
She has a question. Don't go back to yours until they have done at least the first step of getting the common denominator. Does everyone know what they're doing?
Wait, question. For this, like the last problem I looked at it, like we have to change this. You know what I mean? Like sign over something.
We want to write this whole side. Don't worry about the equals.
and then the right side.
Wait, and this too?
Basically, 1 plus 2 sine theta plus sine squared theta plus cosine squared theta over all over cosine theta.
Here?
1 plus 2 sine theta over that. And then I'm kind of lazy. I don't really know. I figure it has something to do with 2 sine.
So we cosine square.
And then you can make it one big fraction with that FOIL. So it's all over the small.
Do I put plus 2?
Bruh.
I'm curious, not how you're doing individually, but how your group is doing. Meaning, at this point, does everyone in your group have this written down first of all? Because some groups it's a no. And then my second question is, if you have this written down, did you guys collaborate enough to where everyone in your group knew at least what they were supposed to do? to get the common denominator. Did your group pass or fail what I asked you to do? Of course. You'll be failed. Now pause. Any groups not have this written down because you truly didn't understand it and you weren't just choosing not to do it? What am I doing right now? Common denominators multiplying him by him and multiplying him by him. The same thing I would do if I had a 1/2 plus a 1/3. I need to multiply this guy by 3/3 and this guy by 2/2. I'm bringing it back to numbers so you know the math of what I'm doing now that there's trig. Does that make sense? Okay. So, I mean, if you at least wrote that down, couldn't you at least try to keep going? 1 plus 2 sine theta, because Justin, you are doing what? Where'd that silly 2 sine theta come from? Boiling. Plus sine squared.
Oh wait, no.
Does this look familiar at all to something from section 5.1? Yes, it should. Study. Yep. Sine squared theta plus cosine squared theta, Pythagorean identity, that's a 1. And what's 1 plus 1? And Emma, you're the one that's been getting this one. Well, you did it once, and then I keep asking. Now what? No, don't cross out. It was under the square root.
You take the factor out the 2.
Factor out the 2. With trig, we can always factor out if it's a common. A GCF. You got it, you got it. Reduce, reduce. What's 2 over cosine?
It's secant.
Yeah, it is.
Wow.
Dun, 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 dun. Oh, is it? It's not new, but maybe it's new this year. I don't know. For some reason, I get into like rhythms, and then one year gets me doing one thing, one year gets me doing another one. And then one year I had something that I can't even like remember how I did it. So I guess I did it a lot. It was like a something when I was really excited. I was at my desk. Did I lose anyone? And if so, where? 80. Does that make sense?
Yes.
Good. Nikki.
I did that thing, I did the distribution, and then I put 1 plus sine squared theta. And I don't know why that's wrong.
Like after this, you did 1 plus sine
No,
squared?
right there.
Right here?
Like instead of putting
You killed a puppy. Because you saw that it was the same thing, and you're like, sweet, squared, squared, instead of realizing it was a first outer inner where you would have a plus 2 sign with the sine squared. See it? So you made that mistake of squaring and just bringing in the squared instead of foiling and getting it all. And technically, if it helps, there is something that some people memorize about how to square a binomial, where it's a squared plus 2ab plus b squared. That's always going to happen, that you could memorize. Kind of like the whole differences of squares thing. But I don't know, back in Algebra 1, you guys were memorizing so much and learning so much that it's, I don't know. For some of you that might help, and for some of you it just makes it worse. Vanessa.
For like the 2 sine, what she was saying.
Yeah.
So it's like 1 plus 1.
Because it was 1 sine plus 1 sine. When you do the outer, it's 1 sine theta plus 1 sine theta, which is 2 sine. You see it? So your first was 1, your outer was sine of theta, your inner was sine of theta, your last was sine squared, and so we combined those like terms of 1 sine theta plus 1 sine theta. So just think your first, outer, inner, last. Yeah. Sorry, I didn't show all the steps of foiling, we just kind of jumped there because some people difference between this one, where we started doing math right away. I don't know, fractions, common denominators, whoosh, or the one before, where we started plugging in right away. You see, there are two different approaches, and it depends on the problem. What was different?
Started with trig.
This started with a lot of trig, and it started with everything all together. It's kind of like, what math was there to do? Can I, like, cross out the thetas and the ones? No, that's totally illegal. PEMDAS is holding together the numerators and denominators. They don't match. Some of you kind of tried to do math by, like, getting squares and stuff in, but that was super illegal. If there's no math to do, okay, try to plug in right away. If there is math to do, then try to do the math, like the common denominators. So what do you guys think about this one? Write it down. Pause. Write it down, pick a side. Because depending on what side you pick, maybe you start with the math, but maybe you start with the plugging in. This is the one side you pick. All I want you to do is pick a side. And tell me if you're starting with math or plugging in. Don't even stress about getting it wrong. Pick a side, starting with math or plugging in. Did you say I ran? There are too many low voices back there. No, 1 second, pardon. Which side do you guys choose? Left? What'd you start doing? Plugging in or math? If you choose the left, I think math common denominators is a smart way to go. If you choose the right, making up stuff and multiplying by a conjugate, probably the way to go. I don't know, I think the right's harder. I think there's less to do on the right. I'm not saying you're wrong, I'm not saying it's impossible, I'm just saying it might be a bit trickier. Because on the left, I'm like, I guess I could do a common denominator. You don't get 0? Because you gotta multiply top and bottom. Or you could change the tangent to be a sine over cosine. Maybe you could have started plugging in on the left too. Because who wants a tangent to get to the other side? I don't, do you? So here's a question. Do we go right away to a common denominator that will use tangent? Or do we go straight for the tangent and make him sine over cosine? Believe it or not, I could probably make either work, so I'm more actually curious as to what you did or what you thought, so I can go your way. Common denominator? What'd you do? You didn't. Were you thinking plugging in for the tangent or common? Okay. So I'm hearing common from most, so let's do common. Nice thing is we don't have to FOIL though, because we just get to distribute, right? I mean, FOILing is distributing, but whatever. So I have a cosine minus a cosine tangent minus a cosine. I had to FOIL the other one. I FOIL. It's 1 plus sine times 1 plus sine. First out or in the left. He had 2 terms. This one just has 1. This one's just cosine.
Well, on the denominator, I'm hoping it's going to go away. So
Numerator. And your numerator is stuck by PEMDAS also. Nikki, what's wrong?
What chapters are we going to do this year?
We're getting all the way to number 12. Number 12 is the most important for calculus. But we're skipping number 11, three-dimensional vectors, and just doing chapter 6 vectors. And then we're only doing part of chapter 10. Random. Hey, cosines cancel! Hey, we're stuck. Don't you dare cross out those tangents. But can't we make tangents something maybe helpful? Yeah. Right. Yeah, because now don't I have something, but it's not the right something? Aw, man. I have something, but I'm not done, and it sure felt like it was like a done step, didn't it? Like, ooh, I'm not done. I haven't done bad math. I got a common denominator. I did get rid of some stuff, but now all of a sudden I have still a tangent. Do we have to get rid of that tangent eventually, yes or no? Yes, we have to get rid of it. So, okay, you guys didn't want to do it earlier, but what do you have to do now? Yeah, careful. Sine over cosine, right? You told me cotangent. So I can make negative sine of x all over 1 minus sine over cosine. Hey, why did we review complex fractions at the beginning? Because if you go plugging in quotient or reciprocal identities to a fraction, you're going to have a complex fraction. Now, my way says multiply top and bottom by cosine. So where you would get negative sine, cosine, all over, you would need to distribute, which would be a cosine, and distribute, which would be a minus sine. The rest of you guys, you had a way of doing complex fractions. You can do that way of complex fractions if you would like. You should end at the same place, and we're like, oh, we're so close. I know, I'm tapping my fingernails, I'm sorry, but now what? Again, do you see how? Because one little baby math step and we're done. Factor out negative. Do you see it? Yeah. Spencer sold. He sold. We'll say you passed the baton. So, pull out a negative. Well, maybe a good pass looks like a steal. A negative over a negative is a we got it. Factor out a negative, and you can change any signs you want. Dun, dun, dun. Careful. Have your notation be right. Show me that you actually got to the other side. The other way? Oh, the one way. The other way that you guys could have done it that's more like what you're used to would have been a cosine x over a cosine x. The long way of simplifying. No, I'm not. You can't You have to divide. Okay. Wait. Division is multiplication. Multiplication has to distribute over addition. So you can't just divide 1 and not distribute it. That's like the legality of it. Hey guys, have you done some examples? Whoa. Good morning. Have we done some examples?
Yes.
Nice. Are they exactly like homework problems? Probably not. But are there similarities? Yes. Are you going to have to do common denominators? Yes. Are you going to have to do plugging in with complex fractions and simplifying? Yes. Are you going to have to sometimes do math and plugging in? Yes. Try something. Here's the hard part of every single homework problem. You know what the answer is supposed to be. You're just trying to get there legally and not just be like, dot. Okay. Do the best you can. Come tomorrow and you get stuck on. And we're not checking even because you already know the answer. It's good. Sound good? Okay. Hang out. You guys have about, don't leave. Oh, they're all outside. And Mrs. Price wants to talk. All right, fine. Bye. Don't make trouble on campus and I'll see you later. There we go. Doubted.
Crafts class. Oh, that's new.